1.3, rate of change and slopes. Here we go. Your first definition of the day, ratio of change. Rate of change is a ratio that compares how much one quantity changes on average relative to the change in another quantity. That is a ratio that compares how much one quantity on average changes relative to another quantity. All right, now, typically speaking, these go with your word problems. Rate of changes do. Okay, rate of change can be, it doesn't have to be straight lines as you will see in the second example. Okay, they can be non-straight lines. All right, so these have to more deal with your scientific experiments, your table of data, things like that. Okay, but typically the book is very straightforward about what they want you to do. The process to do it in, basically you figure out the change in y, whatever that may be, divided by the change in x. Okay, so you do the change in y over the change in x. And they throw this in there, I throw it in there. Sometimes on the occasion you'll see that written as delta y over delta x. Just means change in. Okay, it's a little fun fact for the day. You won't see it often in here written that way. Sometimes you'll see it maybe in a science class or as you get into upper level classes in physics and in some math courses depending on what you take. You start to see more and more Greek letters. So I start to try to sprinkle them in every now and then just so it's not completely foreign to you guys whenever you do get there. Okay, but I won't ever use delta y over delta x, just so FYI. Okay? Okay, so rate of change, change in y, divided by change in x. So the table shows the temperature of a solution after it has been removed from a heat source. Okay, find the rate of change in the temperature for the solution. Okay. It's pretty safe to assume that your first column is going to be your x column, your second column is going to be your y column. All right, that's a pretty safe assumption to make. All right, now, what you need to do then is you have to find the change, the distance between your two x values and two y values. And whenever it's very vague, I guess is a good word, as to which ones to use, I always use the N2. Okay? I always use the N2. And then what I do with those is I make them two coordinates. So 0, 143.6, and 12, 118.4. Okay. First row of data right there. Second row right here. Everybody see that? All right. Once you have those pulled off, the next step is to make is to figure out the change between those. Okay, so you go like this. You go your wides on top. So 143.6 minus 118.4 divided by, and now you go to your x's and you go in the same order. So 0 minus 12. Any questions so far? Everybody good? Once you have that, now you actually do the operations up top and on bottom. So 143.6 minus 118.4, I believe, gives you 25.2. Is that right? Over 0 minus 12 to give you negative 12. And you do that division to give you negative 2.1. Okay. And then what that means is that every minute that goes by, on average, you know, the temperature of this solution is decreasing, excuse me, decreasing by 2.1 degrees, right? So from 0 to 1 minute, 1 minute to 2 minutes after you take it off, 2 to 3, 3 to 4, 4 to 5. Okay. Now, as you can see, it's not exactly that far, you know, stretch it out from here to here, right? It's an average between 0 to 12. On average, it decreases 2.1 degrees. Okay. That's also why it's negative, is because the temperature is getting colder, right? You pull something off the heat, it's going to start getting colder, assuming you're above room temperature, and seeing how we're at 143 degrees Celsius, I would say we're way, way, way above room temperature. Okay? Any questions on that one? Everybody good here? One next. Maybe. There we go. Okay. So another version of this question that they like to ask you a lot is with graphs with sales and stuff. So we have one here. Use the graph to find the average rate of change of the percent of total music sales for both CDs and downloads from 2001 to 2008. Alright. So first thing I'm going to do, I'm going to make these percentages a little bigger so you can actually see them. So we got 89.2 there, 77.8, 12.8, and 0.2. Okay? Those go where those boxes are, right? See that? Now, it's asking for two different questions. It's asking you for CDs. Do it once for CDs. And then it's asking you to do it once for downloads, which I'll eventually write down here. All right, so let's focus on the CDs first, okay, which is the blue graph up here, right? Everybody see that? Now, what is considered our X variables and what's considered our Y variables in this case? What's our X? What's our Y? Like last time it was temp and minutes. Okay, it's got to be something this time also. What's our X and what's our Y? Flip it. Year is X, yeah. And percents are Y. Okay, see how years are on the X-axis, right? Running a long ways? That's how you know it's the X-axis. X, okay? That's not coincidence. All right? So year is your X, percent is your Y. Now, a lot of the times, this is going to be, these problems will be very straightforward like this. Okay? It'll say, you know, do it from 2001 to 2008. Okay? So you look, and then the only points they'll give you are the ones that you're supposed to use, the 2001 point, the 2008 point. Okay? So you really don't have to read the graph and interpret it a whole lot. You really just need to pay attention to which order you put them in. Okay? So since your percent is your Y's, we need to do the percentages first. So I'm going to go 77.8 minus 89.2 for my Y's. Dividing that by my X's, and you have to make sure that you line up which X's they are talking about, in this case the years. So 77.8 goes with which X? 2008. So since 77.8 went first up here, 2008 goes first down here. See the correlation? Minus 2001. Do that subtraction. So you get negative 11.4 divided by 7. Whoops. Which gives you what, about negative 1.63? Rounding. And then you do it again for your download. Same process, same way. Get your percentages first because those are on your y-axis. So 12.8 minus 0.2. And then do the years they're associated with since those are your x-axis. 2008 minus 2001. 12.6. Divided by 7, which I believe works out to be 1.8. Yep. Next up, slope. This one we should all be familiar with at least a little bit. Slope, definition of it is the ratio of the change in the y-coordinates to the corresponding change in the x-coordinates. Alright, so it's the ratio of change in the y-coordinates to the corresponding change in the x-coordinates. The nice part about slope is it always pertains to straight lines. So that means it always pertains to ordered pairs. So that's why they throw the coordinates in this definition. Okay. Now, to figure slope, it's very similar to finding rate of change. You do the change in y coordinates divided by change in x coordinates. Okay, which is essentially the same way as finding rate of change, right? Change in y over change in x. Except this time, since they're actually coordinates, you can name a nice little formula for it, which they do here, y2 minus y1 over x2 minus x1. Okay, make sure you write this down. That's your slope formula. y2 minus y1 over x2 minus x1. Alright, so find the slope of the line that passes through the 2 points of negative 4, 3 and 2, 5. Alright, so here's how I do it if I'm not for sure, okay? What letter comes first in the alphabet, X or Y? X, right? Okay. Same thing for the coordinates, right? X's are first, Y's are second. So here's what I do. I go X, Y, X, Y. This is my first X, this is my first Y. This is my second X, this is my second Y. And Mr. Mormon told me to make sure I remember that Y2 minus Y1 over x2 minus x1 is my slope formula. After that, all you have to do is plug it in. Okay, so plug them all in. So y2 is 5, y1 is 3, x2 is 2, minus x1 is negative 4. Do some math, clean them up. 5 minus 3 gives you 2. 2 minus 4 gives 2 minus a negative 4, sorry, gives you 6. And always with mine fractions, you reduce. So 2 6 goes to 1/3, and you got it. Okay. Now, I'm going to do this the second way, and you guys tell me if I'm going to be okay or not. All right? I'm going to do it. Let's see here. 3 minus 5 over negative 4 minus 2. All right? Is that going to give me 1/3? Yeah. Yeah. 3 minus 5 is negative 2. Negative 4 minus 2 is going to be negative 6. All right? Negative over negative means positive. 2 over 6. 1/3. So I'm good. Okay? So I completely flipped the order of the points. All right? See that? That's what I did. That's it. I did 3 first instead of 5. But then I went ahead and did negative 4 first instead of 2. Okay? So I completely flip-flopped the order of points I did. Excuse me. Now, where you're going to get in trouble at is this. Do not write this down because this is wrong. All right? Where you're going to be in trouble at is if you go 5 minus 3 over negative 4 minus 2. Okay, see how I went y2 minus y1 over x1 minus x2? Okay? You have to stay consistent with your points. Okay, if you use the first ones, if you use the second one's y first, you got to use that x first. If you use this one's y first, you got to use this one's x first. You can't crisscross or flip-flop which one you put first. It doesn't matter which one you put first, as long as you do it with both the top and the bottom. Okay, any questions on that? There's 2 for you. All right, so x1. Oh, let's go back to doing black ink just to be safe here, huh? x1, y1, x2, y2. So you go at y2, which is 5, minus y1, which is negative 3, over, go back to the same coordinate you started with, right? If you do start with the right one, go back to the right one in your denominator. So 3 minus 1, 5 plus 3 gives you 8, 3 minus 1 gives you 2, 8 over 2 gives you 4. Okay. And the second one, find the slope of the line that passes through the points negative 8, 11, and 24, negative 9. I'm going to go the other way this time just to say we can. All right, so x1, y1, x2, y2. Remember, it doesn't matter what order you do them in. So I did 11 and negative 9. As long as you go back to the one that you started with. So negative 8 minus 24. Okay, so it's all about staying consistent with the order you do them in. All right, 11 minus negative 9 gives you 20. Negative 8 minus 24 gives you negative 32. And that reduces by 4 to what? Other way, Miss Pearson. Negative 5/8. Yep. Okay. All right. Now, I'm going to point something out to you guys real quick I want to make sure we're all aware of. The numerator on this one ended up being positive 20. The denominator ended up being negative 32. Everybody see that? I moved the negative up to the numerator. Is that okay? Yeah, it is. All right. As long as one of them's negative, that negative sign can be either one. I want you guys to get in the habit of moving it to the numerator, though. Okay, if your denominator is negative, move it to the numerator, just so that whenever we do start graphing lines again, and we have to graph according to slopes, we can say, okay, we're going to move down. We're all on the same page of whether we move down first or up first. Okay? So start getting the habit, moving your negative signs to the numerator. Okay? Any questions on so far? Alrighty, cool. One more problem. It's a nice one. I like it. Find the value of r so that the line that passes through each pair of points has the given slope. Okay, so you have 10 and r in one order pair, 4 and -3 in another, and then they tell you that m, remember m is your slope. Okay, remember that from yesteryears? M is 4/3. Okay? So they essentially give you everything you need to find that missing coordinate. Okay? Now, the way you do this is you use your slope formula. Okay? So you have your x1, your y1, x2, and y2. Okay, so I'm going to go in this order here. All right, so r minus -3 for my y's, 10 minus 4 for my x's, and that slope's going to equal what? 4/3, right? They tell us the slope this time. What we're missing is this coordinate. See that? Now, once you have that plugged in, you got some cleaning up you can do. Okay? The top, you can make r minus and -3 what? R plus 3, good. The bottom you can make 6, 10 minus 4. Equals, and then do 4/3. Okay. Now, from there, a couple different ways you can go about this. Okay, I'm going to teach you just one though, and that's cross multiplying. Okay, so when you cross multiply, remember it's when you solve equations, you multiply these two things together, and you multiply these two things together. Okay, the pink two things, you do 3 times r plus 3 equals the blue, which is 6 times 4. Everybody remember that? Yep. Which means on the left side you do what here? Distribute. So 3r plus 9. 6 times 4 is 24. Subtract 9 off of both sides. So 24 minus 9 gives you 15. Divide by 3 to get a final answer of, I'm going to move it way to the left here, r equals 5. Homework is page 24, 1 through 8, 31, and 32.